So yes, my name is Niklas. I come from Lendager Group, Lendager Architects, which is an architectural company that work with circularity in the built environment. We've done so only. We've never done normal standard architecture, and I've called this one Ukraine reuse. It's a big part of how we work and what we work with. Yeah. My name is Niklas. Here I wrote that I'm also a solutionist, and that's because as a company I believe that we work with finding solutions to problems, big or small, local or global. That's why our organization is built up on a triangle like you see here, where we work as a normal architectural company with architecture and planning. Then we also do sustainable consulting, because circularity has been part of our organization for 12 years, and we've existed for 12 years. So we realized we know something about circularity that's beyond just architecture. It reaches into so many other businesses, and then we also do research and development when we develop new products, new ideas. Then I wrote this hopeless architecture, where F. Scott Fitzgerald, he said once that the test of first-rate intelligence is the ability to hold two opposing ideas in the mind at the same time and still retain the ability to function. So exemplified, one should, for example, be able to see that things are hopeless, yet be determined to make them otherwise. I really believe that the situation right now in Ukraine suggests such a mindset. So, and for all of us not being in Ukraine, but just fighting climate change, we have to have the same mindset that hope is still an option. Just changing the slide. So yeah, we live in the Anthropocene time here on Earth, and we are very inspired in Lendager by Christian from Humboldt, who made many years ago made some very artistic drawings of how he imagined that the layers of the Earth was could look like. It's not scientifically correct, but it's an idea of understanding that we are more joined holistically than just our egocentric needs and behavior. This is a huge part of our methodology. Also, the way we look at things is that we're not trying to invent new things. We're rather trying to actually reconnect with our own past and understand that being more sustainable, being more holistic is something that we've always been, but we changed a lot in the last 70 years. So our change making as an architectural company, I have 3 examples, and then I have some knowledge that I'd like to share also. One of our projects is the Upcycling Studios. It was finished in 2018. So all the project development was between 2015 and 2018. It's a pretty standard row house typology where we try to mix in a new way of living, where there's both the option to have an office and to have homes. This big space you see out here is the commercial area that's connected to a big commercial building on the other side. Then the rest of these floors are the home for the people living there. It's a huge, very huge project of interest for people living there, and there's the waiting list that's so long that we're not even we're lucky if we get to see one of them without anybody living there. But the project is what I call naked architecture, and it consists of 3 primary resources: wood, concrete, and windows. And in all of these, we try to solve an issue. So first of them is that concrete plays a huge part of our carbonization and globally. It's cement alone is more than 6% of the global CO2 emission. So and we are building more and more structures in concrete every single year. So we try to fix this by looking at how can we actually work with concrete and then use it again. So in Copenhagen, they were building a metro project, and then we got all the scrap casting from that, miscasting, the broken casting, and crushed it and put it into this new concrete. So 45% of the concrete is old concrete from a metro project in Copenhagen. And we built our own factory on site in order to do it, because the industry was not at that time, and is not still always working with us. The other part is the windows, where we gathered 20-year-old windows, 2-layer thermal glass that's been taken out, and then it's been changed out for new 3-layer windows, because we have this thing called an energy renovation. I would ask the question if 20-year-old windows are the ones to take out, but that's how it is, and that's how it's been done. So we look at the resource we get. That's a well-functioning 20-year-old 2-layer glass. As you can see here, the first photo is how they look when you take them out. And the second one is when we take them out of the frame and clean them and go through a very thorough checking list. We did something called a body age test on the windows, where we test how long life they had been living at the time we were getting to them. You could also see in the previous slide that there were some design struggles and stuff like that. So in order to reach this 2020 regulated energy house, we actually built a double frame where we put on 2 layers of 2-layer glass, old glass, both of them. And as you can see here, in everything we do, we try to fix the problem within a known parameter. So the window works just as a normal window. We don't change how the window works. We only change the prerequisites, which is the reuse and the using of the fine existing resource. Here we have the wood. All the wood in this project is cut off or simply just discarded wood from a floor maker in Denmark. So the cutoff is because they deliver full-length planks to various projects, and then they have cutoffs between 60 centimeters and 2 meters, and that's too small to deliver to clients. So we got that and used it for the flooring, and then all the interior walls, which you see here in wood. And all the cladding on the exterior were made by a big chunk of wood that had this wood disease, which gives a miscoloring. But the miscoloring is not functionally anything wrong with it. It only aesthetically. And this is also a big point, is that we look into how to optimize resources generally, and not only looking at reusing resources or using the right resource, also optimizing the use of the resource we use all the time. Here's something about the CO2 savings, 82 on the windows, and the project as it looks, and this is the commercial part of it, how it works. Just to give an example of that, on this time I was designing these windows manually, and I spent 107 hours on doing this design. Then we thought, well, that's not going to work in the future. So a huge part of what we do is also try to optimize on our own work experience. So what we did is that we actually created an algorithm, and this algorithm is being tested and optimized all the time. And putting it into that algorithm, we could actually get out of the computer more than 200 different designs within 600 seconds. So now it's merely a matter of setting up some rules and then using the human eye at last to make some decisions. This is really interesting also in regards of how we can actually go in either in Ukraine or other places to actually do some scanning and optimizing of the rubble, the resources that are available, and then use AI as best as possible. These are some of the numbers, how much of it is upcycled in weight, how much is upcycled in CO2, and how much is the upcycled resources in cost. This one is another one of our projects called the resource rows. As you can see here, something clearly going on. All these brick units are cut out of existing bricks. We did this because 10 years ago, we figured there were so many empty houses in small villages and people were moving to cities. So we thought, could we move the house with them to the city and then solve an issue as a resource being something that you actually take with you. The project here is both row houses and apartments, so we had to fix this within 2 different typology structures. We in order to succeed with this, we invented a new system, a new way of cutting out, and we also discovered that since the 1960s, a lot of cement has been mixed into the mortar between the bricks. So it was actually not even possible to reuse the bricks just by taking them apart, because it's not possible to take these buildings apart. So every single building built from the 1960s and up until today, they have mixed in mortar, cement into the mortar. So that's why we actually came up with this idea of cutting out, and then we created a system of how to do that. As you can see here, we also developed a tool. There's a crane that's lifting up the element, and then we reuse the old installation as when we do the transportation. We also optimized on how we could transport. So this pallet you see here in the video, there can be 4 of these elements on one pallet, so we could optimize on the transportation. It's really a matter of collaboration. I needed these guys to help me. I needed them to be part of the inventing the solutions. And these guys up here, they were the one making the elements so we could actually get them onto the house, onto the structure. Also, again, I need them to be part of finding the solutions, sharing the ideas, sharing the knowledge, also sharing the ownership of the idea is a crucial part of how to succeed with this. Yeah, it's a really interesting video. You can see over 6,000 square meters of facade is cut out and put into this factory, and then it's been put into new elements that have been transported to the factory site. Just skipping forward here. This is the other than that, there's again there's these metro project. What we all of a sudden we were gotten a call from the municipality of Copenhagen that they had all of these wood chunks. As you can see, they are the ones between the tunnel elements for the metro project. And they asked us, do you know what to do with it? And we suggested that, well, we could burn it, but use it and burn it like in a Japanese way. And then they asked, do you want it? And they had 800 tons of wood. And we said, oh, well, wait a minute. And we had to find a place to put the 800 tons. 2 weeks later, we call back and we say, well, we have 800, we have a place to put the 800 tons. And they had already thrown away half of it and burned it. So things move really, really fast in the construction industry, and time is the only thing you don't have when it comes to building and building new projects and building sites and all of this. This is the project on the interior side. The bridge you see here in the middle is an old TT concrete element from a warehouse factory that was just 2 kilometers away that were being taken down. Because what we did here is that we built not only the courtyard as a social place, we built the entire housing as one big social housing, you could say. So we built one shared roof terrace for all people living here, both them on the row houses and the ones in the apartments. So they have one big roof terrace where they have now more than one level to be social on. And when we do interviews out there, it's really, really something that everybody emphasizes. There are many buildings next to it that don't even have a roof terrace, and if they have, it's only like for for the ones paying the most money to be in the best apartment, so-called penthouse apartment. One more thing is that also we have these roof houses on the top. They are built entirely out of scrap. So 30-year-old windows, fully discarded wood from a wood maker that because they treat wood and then they were mistreated, and green roofs, and the terraces are made also out of the wood from the metro project. So we really all this wood above the windows is also from the wood from the metro project. All the interior flooring is also discarded wood from a wood maker. So a lot of resource efficiency on this one. Yeah, this is again the numbers here and the cost. Not going to bore you too much with that. The last project I'm going to show you is a high-rise. This is a new build high-rise in Aarhus. It's been built right now. It's going to be one of the tallest buildings made in wood. So it's going to be 20-story high. And the entire structure is going to be wood. Besides the foundation and elevator shafts are going to be in concrete. And then the entire facade of this building, the cladding on the outside, is going to be remade, repurposed aluminum, not remelted aluminum, but directly from one building cut it out in different size, and then put up on the facade as a new aluminum cladding. 25 years old aluminum. So we save 97% CO2 on reusing that so directly. And what we wanted was to create a building that visualizes the reuse of resources. Another thing we also do in the project, besides all of the other things, you see the metal sheets here, directly reused, is the windmill wings, because windmills is, both for Denmark, is a huge export category for us, because we are kind of like synonymous by wind energy, and it's an image of green energy, and it's very good. But the thing is that after 20 to 25 years, all of these windmills are taken down because the cost of maintaining gets too high, compared to the efficiency you get out of the power. So we tried to look into how can we reutilize that, because the modern windmills are more than 100 meters long for just the wing. And they're hanging in one point. So we thought, how can we put this into the structure again? So what we do is we use it for solar shading in this project, and this is the wood structure you see here, and then on the facade on the outside of it, it's going to be the windmill wings. As you see here, the big problem is today we cannot undo the making of the windmill, so it's just been buried in the ground. This is the way we look at all possible problems, waste issues, is that we see opportunities, we find solutions for how to do that. These are numbers that are increasing in the amount of windmills being built, and then also windmill wings being taken down. Normally, they would just go out here to the end of life, where you burn it or you bury it. This is where we get in, and then we say, well, let's find a different way. We harvest, we dismantle, we cut, we storage, we find out how to put it into the built environment with all quality assurance, warranty, all of these things, and then we design, we do a new mounting system, and then we have it on the structure. This is some process images just to show how hands-on we are when we do these things. Huge fire testing, just to that's a big part of legislations in Europe, I guess. All of the materials on the building. This is hopefully how it's going to look. The last thing I want to share with you, how much do I have? Like a few minutes?
You've got 2 minutes left.
Okay. So how do we do all of this? Well, there's two things that's key to how we do it. One is, of course, the mindset is that we need to do something differently. But one of our tools is, as I wrote here, is mapping. Mapping is understanding. We can only solve what we know. It's crucially important that we start to actually accept that mapping is a part of how we actually understand the problems we have to find solutions for it. This image there was an example of something in Norway. Just to visualize how that translates in our mind is that when we do these mappings, then we actually get something we can talk about, all of us together. So we are not just cross-communicating. Now we can put something in the middle that translates into a tool that everybody can work the way out from. And what we do is we try to identify resources. We categorize them into something that has value in order of historical value, or there's a lot of it quantity value, and then CO2 value or weight value. So we put a lot of different elements into these mappings and categorize them also monetarily. So how much money does this represent if we go out and buy new? This is from a specific mapping that we did, where there's in a single project 1.4 billion Norwegian kroners worth of value in what they were just going to throw out. So this is also a matter of repurposing resources in both climate consciousness, CO2 money, and then also what's the availability. And the reason I show it like that is because today we have a traditional value chain. It looks like this. We go from raw material through manufacturing, distribution, design. This is the way we know it today. What we see is that when we want to change this one into a circular value chain, some things change. The point of of action also change along the way. So we have the planning, we have the mapping, we have a design, and then we have selective demolition, and then we have some sort of a material bank, which goes back into redesigning again, because not everything can be as you suggest or figure in the first segment. And then we have to manufacture in a way so things can be distributed and repurposed again in the end. We, of course, have developed a sustainable design methodology. We actually developed 2 of them, but reality is that when we do this, a lot of it is like, it's good to have a strategy, but there's also a lot of points and elements in having a strategy where we have to say, well, okay, it's not going to work if we only follow our strategy. We have to find new solutions, and new problems always arise. My final point is this: what have we learned? We have learned that we must wonder. Never stop wonder. Be in doubt and raise the question. Rather to have asked than discover it's too late. It is all a collaboration. Follow up. Rome was neither built in one day by one man, nor all at once. Never take an immediate answer for the full truth. Always challenge and try again, but with a different angle. It's all a collaboration. And then change. Things will change. They always have, and they always will. Be part of it and grab it, but do it in the speed and in chunks that you can manage. Share your ideas, share the ownership, and people will help you. It's a collaboration. It's really, really important lessons I've learned. And then at the end, we have some dogmas here, which is kind of like not fitting maybe for Ukraine in the moment, but some of them you can take, but the rest of Europe could definitely. Don't build. That's one. And then if we have to build, preserve and repurpose buildings on site. And then if we have to demolish, which I would strongly recommend we should try and avoid, then create a circular building site and reuse materials. And then at the end, if we have to do new build, use waste and bio-based materials to create a carbon bank. That was it. Oh, that was my end. So I hope you all managed to follow along and get some,